What would happen if you peed on an electric fence? When a man's got to go, a man's got to go. But what would happen if you peed on an electric fence? Now, this should be a really easy question to answer. You find an electric fence and you pee on it. The trouble is finding someone brave enough or stupid enough to do it. So before I drop my pants and answer nature's call, I think a little bit of experimentation is in order. Now, we have attempted to recreate the famous Brussels monument mannequin pee. It's not a scratch on the original, but it should serve our purposes nicely. Our chap here is currently just recycling water. So what we're going to do is add some salt to recreate as closely as possible the wastewater our bodies produce. Urine is around 95% water. The remainder is mostly salt and urea, and it's these elements that carry the charge. Now, first thing to do is to switch on the electric fence. Okay, that's on now. Now I'm going to measure the voltage coming off this machine. Whoa, you can see that. Now, from top to bottom on this screen, it's about 400 volts. And whenever I get one of these big peaks, which you see happen now, there's one, it's blowing it way off the screen. But that's no great surprise, because we know this is 6,000 volts. So what I'm going to do now is attach my probe to the beginning of the stream, like this. And what I'm looking for is to see if I get any sort of blip at all. Because even the smallest blip means I'm getting at least 100 volts. And 100 volts is the limit I've set myself. More than that, and there's just no way I'm going to do this. So, here goes. Right, I'm going to move the fence into the stream now. Like that. Let's have a look, let's see what we're getting. I'm sure I don't have to tell you that I'm very keen to see some activity on the oscilloscope. A shock of less than 100 volts would still be unpleasant, and I will be a much happier man when I see some big blips. We're not getting as much through, it's definitely reduced. Whoa, there was a big blip there. Well, that was really big, well, that was at least 150 volts. That's a sight for sore eyes. There was another one. Now I'm getting blips there that are almost the full screen, so that means there's probably almost 400 volts at the beginning of the stream. And that is 300 volts more than the limit I set myself. That's a big relief. The charge is definitely travelling up the stream, and at the source there could be even more than 400 volts. Right, that's all the evidence I need. Now, while I can't tell you exactly what would happen if you peed on an electric fence, what I can tell you from this experiment is that if you did, it would hurt like...
Once again, guys, the potential difference is large enough. It could be...
Southwest
potentially, it could be deadly.
Suburbs say an electrocution yesterday started with an innocent water balloon fight. Alsip police say 12-year-old Sean Thompson was standing in a puddle of water. He received a fatal shock when he grabbed an electric garage door as it was closing. The victim's 11-year-old friend, Jared Gallivan, tried to pull Thompson away, but he was injured as well. Authorities say the garage door opener may not have been properly grounded.
All right, so what's the meaning of properly grounding something? And how does that make it safer? All right, so any appliance, which is a metal casing like that, needs to be properly grounded. So what's the meaning of something being properly grounded? If it's not properly grounded, if there's a loose wire touching somewhere, where will you find the current? The current is going to be on the outside, right? So if you were to touch it, what's going to happen to you? Well, the current doesn't have a choice but to go through your body. All right, so you will become part of that circuit. And then the current is going to go through your body to the ground. So how do you prevent that from happening? Well, what you need to do is you need to ground the device. So what's the meaning of grounding something? All right, I could give you a short little answer, and then if you were to give me back the same answer on the test, obviously I will dock you pretty badly. So I might as well give you the full answer, the technical answer. So let's just connect to the computer. All right, so here's the original dryer, and it's got some loose metal touching it, and then you come from outside, and then you touch it for whatever reason, and then boom, you're not like metal, your resistance is a lot higher than metal, so your body offers a lot of resistance, and if this looks like flames from hell, it's going to feel like flames from hell, which means that your body is going to heat up a lot more than the wire will. Not to the extent that you will glow, but you will become part of a circuit. All right, so you will become part of a circuit. So this is the resistance of this one. This is relatively small, and your resistance is going to be a lot bigger than that one. But you will become part of that circuit nonetheless. All right, so the same current is going to be forced to go through your body. All right, so the current is going to be going through. So what you need to do is you need to avoid that from happening. So how do you do that? That's straightforward. Anyway, so the amount of current coming out of the socket is usually not that large. It's not that much current by design.
The path that leaving electrons follows depends on the material they flow through.
You're not going to glow.
The human body certainly will conduct current, but not a lot. Not like a piece of copper.
All right, so the amount of current going through your body is not going to be large, but it's large enough that it could potentially kill you.
It's no big thing.
if you were to come in contact with the socket on the side,
How are we going to do it?
Fine, we'll do it. Oh, Mama.
Are you okay?
I'm gonna lose that nail.
man, the acting is phenomenal.
It's just...
Michael Richards says, Kramer, it's a sitcom, and I can't believe they paid this much attention to
It's no
detail.
big.
How are we going to...
He's got a clip in his hand,
Fine.
paper clip. He's gonna wet it to increase its conductivity, which you don't need to, and stick it right into the socket. All right, so what happens? It's alternating current. The body freezes up. Beautiful acting. And then there's a circuit breaker that's gonna kick it. All right, by using Mythbusters numbers, I'm assuming that the body's resistance is, I don't know, 10,000 ohms, which it's not. Dry skin could be 100,000 ohms. All right, the current going through his body is probably gonna be about 12 milliamps. If that's the case, it's large enough to give you a heart attack. All right, so that's the current directly out of this.
Oh, Mama.
Are you okay?
I'm gonna lose that nail.
In reality, it's much less than that. So the kids usually take a fork into the socket, they get shocked, but they still survive. The amount of current is intentionally kept extremely low so that people don't get themselves electrocuted by accident. So the question is, 65 milliamps of current large enough to kill? Absolutely, it can give you a heart attack. 12 milliamps of current likewise can give you a heart attack. All right. All right, so what happens if you come in contact with the current accidentally from outside? Alternating currents is what you get from the socket, so it's going to paralyze the muscles. It can travel inward into the body cavity. Once it gets to the lungs, obviously you're going to have a hard time breathing, and at the same time it's going to get to the heart. And then obviously, because it keeps changing direction, it can mess up the heart's electrical rhythm. It can give you a heart attack. If somebody is having a heart attack, what do? We discussed that, defibrillators. So what you do is you pump about an amp of current, more than an amp, into the heart momentarily to stop the heart. So in essence, you're resetting the heart. So it takes about an hour to reset the heart. That's what happens. So in order to avoid this, appliances with metal casings have to be grounded. The grounding usually takes place through the third prong, that takes it to the ground. So which means that there's usually a wire within the structure, within the metal casing. It's usually attached to the inside of it. And so it's just going to take it to the ground. So what it does is, in essence, you become parallel to the main circuit. So you become a resistor that becomes parallel to the main circuit. So the current, given a choice, is going to take the path of least resistance. All right, so this is something that we discussed already. All right, so let me illustrate. The grounding wire does this. All right, so you got this grounding wire. What it does, it's going to set up a circuit that becomes parallel to your body. Grounding wire has very small resistance. All right, so I'm going to keep the resistance extremely low. Your body offers a lot more resistance. And then it just takes it to the ground. That's what it does. All right, so given a choice, the current is going to get to this point. Now it's got an option. Either it's going to take the path of least resistance, or it's going to have to go through your body. All right. So this offers a lot less resistance than your body does. So much of the current is going to leak out. It's going to bypass your body. Right. Does that mean that there's no current going through your body? Well, there's current going through your body regardless, but the resistance of the body is so high that the amount of current that's going through your body is going to be unnoticeably small. So that's what it means. So the grounding wire is going to become a circuit that becomes parallel to your body because it offers a lot less resistance than your body does. The current, most of the current is going to bypass your body. So that's what the grounding wire does. All right, so the accidental electrocution, the amount of current usually is not that large. And the problem usually is the contact time. If you become part of that circuit long enough, the current sooner or later is going to get to the lungs, it's going to get to the heart. If you're not able to separate yourself, potentially it can kill it. All right, so that's what the problem is. All right, so under any circumstance, under no circumstances, should you be touching anything with your palm first. That's when the problem starts. You grab it, you're not able to let go. And if that's the case, you will become part of that circuit. And sooner or later, it's going to do its damage. All right. Electric chair is obviously the same concept, except the whole idea is to get to the heart within a fraction of a second using alternating current and stop the heart and fry it. All right. So they end up using alternating current on purpose. All right. So speaking of the electric chair, the United States is the only country that uses electric chair. It's still being used in quite a few of the states.
They normally see
the first execution took place in New York State. It was Buffalo, New York. And the idea was sold to the guy who was about to be executed that this was going to be a quick and painless death. All right, they said, you're not going to feel anything. Would you be interested? And he said, absolutely. All right, I mean, this guy volunteered willingly. So the question is, can you actually kill through electrocution without causing any undue pain or suffering? Is this a viable method of execution? All right, so this was
Suddenly gripping the chair, this is due to the spasm, they often see steam coming out of their mouths or their ears, and occasionally flames, because the heat of the electrocution melts the fat in their faces, and it sometimes vaporizes and sometimes catches fire. Electricity is an extremely humiliating way of killing people. It's humiliating partly because the person vomits and drools, their tissues swell up like a Michelin man and may burst. They pass water and defecate, and usually there's a horrible smell.
This guy is so polite. Oh my God, defecate? Guys, it's going to shock the shit out of you, literally. All right, and the body's going to heat up. Everything is going to boil. All right, fat is obviously melting under your skin. Flesh is going to boil. Whatever you may have in your body is going to leak out. So you got urine, you got shit. It's going to smell horrible.
What's the smell? Well, the smell is actually boiling urine, boiling feces, and burning skin. Pretty unpleasant smell altogether.
So obviously it's not going to be a pleasant experience to witness it, but the question is, does the person suffer any pain? Can you get to the heart of a person within a fraction of a second?
No.
Stop it and fry it without causing any undue pain or suffering. All right, that's always the question. All right, it's not a question of execution. Can you actually do it without causing any pain or suffering? That's what the question is. Okay, in theory, they decided 100 years ago that yeah, it's doable. You can get to the heart and be able to stop it and fry it. So they conducted all these experiments on cats, mostly dogs, one elephant, a few horses, and they convinced the New York State, the lawmakers, that this could be done, and it could be done effectively. And they thought that this was a viable method of execution. They sold the idea that this was actually better and more humane way of killing people. They said they hang in. It's British. We don't like British, so don't use that. Guillotine, that's French. No good. Firing squads, that's too military. It's not the American way. So United States is the leader of technology. Technology is the way to go. All right. So turn on the machines, generators, boom, the person's done with within a fraction of a second. So they've done some demonstrations, and the lawmakers said, okay, let's do it. All right, so here's the depiction of the first execution from Buffalo, New York. Reenactment. Immediately I see a problem. What's the problem? Person is grunting. That's what the problem is. If the person is grunting, obviously the execution is not carried out properly. It's not supposed to cause any undue pain or suffering. The biggest problem is the person is able to grunt. That's a huge problem, which means that the lungs are working fine. He wants to yell and scream, he can't because the muscles are paralyzed. And the current is in the body, but it's not within the body cavity, which means that it's right under the skin. It's melting the fat. It's within the bone marrow. So this guy is just feeling every single jolt. All right, so eventually he stops grunting and they stop the execution.
He's still alive.
Minutes after.
Once they notice that this guy's still alive, so they continue. Because at this point, it's in an experimental stage.
Kelmler died. Dr. Southwick, who was one of the instrumental.
Do you guys hear the static? Yes or no? All right, so after the break, I got to set
this. Men instrumental in the invention of electric chair said, today we live in a higher civilization. He was pleased. He said, I am one of the happiest men in the state of New York today. And over again, there was talk of increasing civilization, a higher civilization, and the word progress appeared repeatedly in the arguments for the electric chair.
The warden said, Kemmler is dead. And then somebody in the crowd yelled, he's still breathing. And Spitzka screamed, get the electricity back on. This time they left it on for 4 minutes, until Kemmler's body finally caught fire. And it was at that point that they gave the signal to shut off electricity. And through the whole room, they were in the same room as he was in, and they were probably 10 or 15 feet away at the most. The whole room was filled with smoke and the smell of burning flesh. And it was just a horrible scene.
They didn't have the generator tied down properly, so when they were putting the current through Kemmler, they were running the generator with some belts. The belts were coming off of the generator, and the person had to be up to kind of push the belts back on as they're getting the electricity into Kemmler's body.
Well, the Attorney General actually fainted, ran out of the room holding his stomach, and then he fainted. Most of the other witnesses were terribly shaken up by this, because they had, I think, like Kemmler believed, that this was going to be a quick and a painless death.
It is usually believed, because they want to believe, that death is instantaneous. It simply isn't true. The fact is that they die due to asphyxia, which takes from tens of seconds to minutes. And that is because the electric current stops them breathing while they can still feel.
All right, guys, take a break for 10. Be back within 10, and we'll continue the discussion. Let me check to see what's wrong with the computer.